Thanks for watching. Today I'm working more on my stock market model. Before I get into it, I'll go over really briefly the goals and what I've done recently, what I'm working on today. So, let's see. Um, these are the goals and layout for the model. Goals to make money in all regimes, beat the S&P 500 by a significant margin, um, probably two or three. Really, I'd like to 3x the S&P at least. But if the S&P is going down, I don't want to beat the S&P and lose money. I want to be making money no matter what. Second goal is to create a usable. So I'm writing all this in Python code. So my second goal is to create a usable tool that anyone can use to create these sorts of models for themselves. So this is the layout. First, I'm starting with a stock universe. You don't want to use all stocks that you have access to. So I'm going back to 2011. So I have data going back to 2011. I should say one of the main requirements on the second goal here is that everything should be free. So I found a good free data source that gets updated every day, going back to 2011. I'm isolating stocks from this in a stock universe. Basically, you don't want to include low quality stocks, penny stocks, low volume stocks, test tickers, things like that. Those will throw the model off. I'm not including ETFs. I'm only including common stocks, which is things like Apple or Tesla. Um, ADRs, which is foreign stocks listed on the U.S. stock market, and real estate investment trusts, because those have similar price dynamics. I'm then using that data to generate a returns model. I've got a really good returns model going now. And so now the current thing I'm working on is the portfolio model. So I'm trying to decide right now whether this is going to be a model or just a machine learning model or just a set of rules that I use. Um, so yeah. So here's after a lot of work. I started this at the beginning of the year. So after over 3 months of work, this past Monday, earlier this week, I got a really good returns model that you can see here. So we know it's good because the metrics it's getting. So this is a single model training on approximately 2011 to 2018, validating on approximately 2019 through 2022, and testing. This is very rough, but testing on 23, 24, and 25. So if you look at the performance, is this it? No, sorry, wrong model. This model here. So how do we know this is good? First thing, information coefficient. I want to get 0.01 to 0.02. I thought this was better. Oh, what is this? Model 12 with improvements. That's not it. 0.0262. Oh yeah, this is it. Is it? Yeah, I guess that is it. So do I put the goals? Oh yeah. So here you can look at the output, the metrics I'm using to assess the model. So information coefficients giving the predictive power. I'm shooting for 0.01 to 0.02. I'm beating that 0.0262. Standard deviation of the information coefficient should be 3 to 13 times the information coefficient. It's about under 4 times the information coefficient. So standard deviation of the information coefficient to information ratio, both on a daily and annual basis, and then the t-statistic, those are giving the stability, information coefficients giving the predictive power of the model. So it's beating every metric, so it's stable and has sufficient predictive power. Then if you look at this is the decile analysis. So how is it performing on each decile. So if you bottom 10%, 10 to 20%, all the way up to the top 10%. Basically, this should be monotonically increasing. Each decile should be performing better than the previous. And that's basically what you see here, with the exception of the 70th percentile, but that's a very slight, that's very slightly off. So this is a really good model. Oh, wait a second here. Oh yeah, that wasn't it. This is the better model. So, okay, even better here, you see information coefficient is way higher, 0.0471. Standard deviation is 1.1468, so roughly 3 times. Information coefficient to information ratio daily, 0.32. On an annual basis, it's almost 2.3. T-statistic, I'm shooting for 1.95. I'm getting 3.76. So that's really good. And then this one you can see is monotonically increasing. Each decile is performing better than the previous decile, with the bottom 10% performing lower by 0.1, top 10% outperforming by 0.05. So next step was to do a walk forward analysis on this. If I'm going through 2020 to 2025, you see it's getting above 0.02 for the information coefficient each year. So then I started looking at how can I implement this into a portfolio strategy. So I was trying to optimize a portfolio strategy. This isn't working really well. I'm not. If I am outperforming the S&P, I am just barely. I'm getting about 15. Yeah, this shouldn't be outperforming the S&P. I'm getting 15% returns over 4 years. And so these returns aren't very good, but the max drawdown is very good. So that's nice. The worst drawdown I got was about 3%. But then you see the rolling sharp falls below 0. Really, this should never fall below 0, and ideally it would never fall below 1. I tried some simple rules-based metrics. These didn't work either. I also tried I don't have this in the PowerPoint, but I tried just weighting the portfolio prediction according to these. So everything below 0.5 selling, above 0.5 buying. That didn't work either. So this was with some quick prediction code, or quick portfolio optimization code I wrote with AI. So I'm going to go through, and today I'm working on writing my own code. So it should be simpler. I should understand the ins and outs of it. But that's basically what I'm working on today. Hey, Sir Night Night. Yeah, doesn't this look great? That looks like tremendous. And this looks really good. But when I'm trying to, yeah, I guess I just said that, but the portfolio model isn't doing well enough. So basically it looks good for the most part, except the rolling sharp. Really, I don't want that ever dropping below 1. I'd feel really good about that if the rolling sharp never dropped below 1. And then I need better performance out of this. That's not beating the S&P. So, yeah, I'm working on building my own portfolio model now. Hey, David. Yeah, I went to college. College, I don't think, is really necessary unless you have some determined career path. I guess it's good. It helps you get into careers, but I don't think that's going to be the case going forward. The only career is going to be working for yourself, using your brain. All right, so let's go back here. And I don't really need this right now. I need to implement my logic. Okay, that's the wrong thing. Okay, here we go. So in portfolio, I'm defining a portfolio, get model, drop unnecessary, walk forward portfolio, backtest. Oh yeah, so I want to make some backtest rules. And then I'm going to optimize this. So this is going to be different from anything I've tried. I'm going to try to add some simple rules, and then optimize this with differential evolution. Rules-based backtest. add rule set. Yeah, so I have these rules. You can put a bunch of rules into a rule set. Um, oh yeah, so each rule has a feature. So add rule set. Um, I need to actually also look into this. Um, so what did I add? My new features. I guess it's in tests. So new feature test. Oh yeah, test features. Test features, rate requests, test rate features. Oh yeah, so these. Oh no, not rate features. Cross-sectional features. So this should be interesting. So when I tried to add macro features before, it didn't work because it was the same for each day. Did I test VIX? Let me look at the PowerPoint. So that's way up here. Um. Oh yeah, so rate features were important. Okay, so this was my conclusion. Macro features will always worsen the performance, which is predicting cross-sectional z-score on all returns because the value is the same for every stock. That's true, but what about so the problem with rates is they're not changing very much. If we look at this, so test features, let's turn the rate test on. Test rate features. Oh, okay, that's already on. So my conclusion was they don't help, but the question is, oh, um, yeah, AI and just the way, basically technology, the way things are moving. Um, but really with AI, the only people, there's a lot of jobs that people get with college where they don't do anything. And I think all that's going to go away. Companies are going to get parsed all the way down to just the people who actually do stuff. And really, what college helps you with is getting jobs. It's like a certification. It shows you can follow rules, basically. And following rules isn't going to be very important going forward. It's just, how effective can you be? So, um, and yeah, so yeah, colleges have gotten overbloated. They're not bad, but I don't think most people need to go to college. So maybe you're one of the college people, but you know, everything that I've made money from, you don't really need college. The college has helped me, but just you know, um, I don't know. I don't think it's very useful. Lots of colleges are gonna stop existing, and then they're gonna have to become effective, and then it will become useful again. But um, at least when I went to college, I don't think that's gonna really help people much. But things are changing. Maybe the colleges are adapting. Um, oh, whoa, it's running the portfolio optimizer. Oops, let's go to tests. Oh, let's see. Get this thing out of here. What is the portfolio strategy you're using? How would you describe the strategy? You could focus on being beta. Why is this, I need to move this up. You could focus on being beta neutral. Good, David. That way you can mute the market impact to the portfolio performance. Beta neutral. Yeah, I do want to be beta neutral. Really, what I was doing originally is trying to maximize the what's it called, the Sharpe ratio, where you're accounting for the drawdown. So you do Sharpe ratio times 1 minus whatever the weight you're using, how much you want to punish a drawdown, times the max drawdown. So that's basically in that model, the results I showed. I really should have documented this better, but uh, the reason the returns weren't very good here is because I was heavily, see drawdown weight 3, I was heavily punishing drawdown. So the good thing is the worst drawdown was 3%. But the bad thing is, that really punished my returns. So I need to kind of weight that. Shooting for beta of 0. Basically, I'm doing some optimization. I'm putting in some macro features and doing an optimization with that. I kind of have a problem though, because I don't have that much data. So if I'm going back to 2011, I can do, 8 years of training data and 1 year of validation data, and then I get this walk forward. But the problem is this walk forward is only giving me 1, 2, 3, 4, 5. Now I'm trimmed down I have to go from 15 years of data for the returns model down to 6 years of data for the portfolio model. So there's a trade off going on. What I can do is go here and where is it? Data, models, model 22. Yeah, so then the next thing I did was, so I can use more years for the walk forward. The problem is this is using less training data on the models. So the models are performing worse because I'm only using 4 years of training data as opposed to 8. The good thing is I have, 10 years of data to train the portfolio strategy on. So I need to look at, is this a good method? Because I'm basically, with 2 models and a finite amount of data, you have to make a trade-off. I could make the returns model worse and make the portfolio model better, or I can make the returns model better, but I need to sacrifice because the portfolio data is going to have less data to look at, it's going to perform worse. And even if I get the portfolio to perform well when I'm only using 6 years of data here, I don't have a lot of years to test it on. So if I want to have the portfolio train on 4 years, I'm only testing on 2 years. And so if it does well for 2 years, that very well could be an anomaly. So I'm not sure how to test this right now. So yeah, basically I need to, so yeah, shooting for beta neutral would be good. But if I just shoot for beta neutral, I'm still, there's a big drawdown risk. I want to, this is the training period, so you don't have to worry about that. But I want to avoid big drawdowns. I also want to avoid drawdowns that last over a long period of time. The latter could really be fixed by optimizing the Sharpe ratio. But I am optimizing for the drawdown, the Sharpe ratio, or I'm taking the drawdown into account. So I need to basically think about this. And so this is all with Bayesian optimization for the portfolio model. What I think I'm going to do is do a returns model, have it walk through the rows. I can try out different rules. Since I've already defined all the features, that'll be easy to try out different rules. And then I'm going to give it, this rules-based backtest and basically give it the portfolio so it only needs to read in the data once, and then optimize this rules-based backtest by trying out different rules. That's kind of what I'm thinking right now, but I need to get a good objective function. Your strategy looks good enough that you don't want your portfolio strategy fighting it. Yeah, though, that's kind of my problem that I have right now. A good method is that you can create fake data. That's a really good method considering your time scale. You could have Gemini generate some synthetic data for whatever time period you want. Yeah, but then isn't the problem with that now I have the synthetic data, so I have to go off of how good the synthetic data is. I don't really know what to do with that either. Um, but that is true. So the it is the case the portfolio model looks good enough that I don't want the returns model fighting this. But let me show you, and really I need to document this anyway. If I go to Portfolio Explorer, yeah, so I made this run simple backtest. This is basically going through, and it's where is it? It's weighting the so it's basically trying what my portfolio model is trained on. So the portfolio model is trained on 5 days. So if I just say, okay, let's weight the portfolio, maybe I'll take the threshold out, give it 0.5. And so now it's shorting everything that's below 0.5 and going long on everything that's above 0.5. And I'm only trading the top N number of stocks per day. Maybe I should increase this, but the more stocks you have, the more slippage you have due to fees. So I'm not sure what to do with that. The model I thought was the hard part, but actually the portfolio strategy, there's a lot that goes into it. So I need to think about this. Anyway, yeah, I could run this simple back test. So if I'm only picking 20 stocks per day, picking the ones with the best predictions, maybe there's some problem with the logic here. How's my battery? Battery's good. So let's go back here. And I'm just weighting them according to their probability, but I could weight them according to a sigmoid function or a tan H or something like that. I'm shorting the bottom predictions and going, let's just run this. So test simple back test. Okay. Let me run that really quick. Okay, let me run that in a different window. You could just smooth your returns out by using a hierarchical risk parity portfolio strategy. Smoothing out returns is good for the mental. Yes, that's definitely the case. C's get degrees. They're not that special. Yeah, I mean, I got mostly C's my whole life. All of high school, I got C's and D's. I almost failed out of community college. Anyway, yeah. the people who do well in college generally are good rule followers, and I'm not a good rule follower, so I, of course, have negative things to say about them, but I'm sure there's some utility to it. I hate bureaucracies, though. I have an aversion to bureaucracies. Um, so this is starting in 2011. So I concluded here the problem is that the rate features are the same for every stock. So that's the case. I mean, they are changing, but how often do they change? So, how often do the rates themselves change? They're changing quite a bit here, so. Oh, these are treasury rates, not um, interest rates. Yeah, so if these aren't improving the model, I don't think the other things should. But I want this sort of information somewhere. So it's making my model worse, but I really think this macro feature information, treasury rates, should should be accounted for somewhere. Let me see what Sir Night Night suggested. It depends on the career path. Yes, that's definitely it. If you're in tech, you can't. Yeah, you can't get a job. Uh, I mean, that's been happening for a while. Kids starting businesses out of high school, but I see all these kids. It's this guy started an AI company. It's like sounds like bullshit. How long? No, it's a. I'm. My plan is to use real money. Basically, um, but I can't have something. How long until I have until I've generated alpha? I don't know. I hope soon. Um, but basically, I've got a good returns model. I need to incorporate that into a portfolio strategy that works. Once I do this, I'm going to start paper trading for a month. And if my strategy does well over paper trading, if it's consistent with the testing, then I'm going to go live with it. So the real goal for this is to make money. Secondary goal is to make a tool that anyone can use to do this for themselves. Because honestly, this is fairly complicated, and you're always going to have to make the models for yourself. But if you have some code, there's nothing easily available in Python, which just you can say, get these features, train it, do all the assessments. You kind of have to write all of that yourself. So um, I'd like to make something easier for people to do that, kind of do the heavy lifting, and then you could spend your brain power exploring model strategies instead of, getting your code to work. And it takes quite a bit. It takes quite some time to get it to the point where you're confident. But um, like this returns model I have, this is really nice. The information coefficient is really high, way higher than the minimum for being able to be implemented. All of these metrics down here are showing it's really stable. The decile analysis looks really good. It's increasing monotonically. Um, and then the walk forward looks really good. This isn't just a strategy that's working because I'm using a convenient data split. If I'm changing the data splits, training a new model for each year it's getting it's beating the metrics that I'm shooting for. So this shows it's robust. Um, Really now I just need to get a portfolio strategy which works. So let me go back to, I dropped out third year to work for a younger friend who started an unrelated business out of high school. Just end up 10 years later. Yeah, that's what happens. But it is true. Sometimes there's jobs that you try for where it's like, they don't consider you if you don't have a degree. That's what I keep encountering in physics. It's basically if you don't have a PhD degree, nobody wants you for research. Um, But they do want you for applied physics, so you gotta have something that proves you're capable, and then you're fine. What do you do, NGK? I forgot. Um, you could smooth out your returns by using a hierarchical risk parity portfolio strategy. Okay, let's look that up. Hierarchical risk parity. Modern portfolio construction technique introduced by this guy. Oh, DePrado. I know that name from somewhere. He invented something. HRP improves on traditional methods by grouping assets into clusters via hierarchical tree clustering, sorting them through quasi-diagonalization, and using recursive bisection. Similar assets are grouped together into a hierarchy based on their correlation matrix, ensuring similar assets compete with each other rather than the whole portfolio. HRP is a probabilistic graph-based alternative. Addresses three central issues commonly associated with quadratic optimizers. Assets are grouped into clusters based on their correlations, forming a hierarchical tree structure. The correlation matrix is reordered based on the clustering results, revealing a block diagonal structure. Weights are assigned to assets through a top-down approach, splitting the portfolio into smaller subportfolios and allocating capital based on inverse variance. So how do I incorporate that? Determines how much to allocate to each stock based on correlation structure. Well, your model determines which stocks to include. My model does not determine which stocks to include. Instead of selecting n stocks and then weighting them, you can use the model Sharp as a signal weighted tilt. Uncorrelated low volatility stocks get higher base weights. Oh, so rather than doing equal weights, I was getting a big drawdown profile, so let me run this simple back test again. Oh, did I just run it? Oh yeah, I'm in the wrong environment. Stock market. Is that is what something that gets better over time? Is this something that gets better over time? What? What is what? I'm not sure what you're referring to. Um, the model? Well, the model gets better over time if I work on it. You're trying to be a decent metal fabricator? Yeah, I don't do that enough. Um, okay, so this guy's running. So we'll see how bad that is. It is pretty bad. No, okay. The problem and then I need to do this. So this will implement rules. I mean, this is just too many rules, right? I could optimize this right here, actually, though. But this actually shouldn't be too hard. So if I go back to portfolio, rules-based backtest. So we have the rule set. We have the portfolio. So then we could say oh, this was what I had in my PowerPoint. So I'm trying two strategies because I have a Roth IRA. So in a Roth IRA, you can't short anything. So, yeah, I don't want to be shorting things. So I am getting really good returns on the long short strategy. Long only strategy is losing money. So I'm not even going to think about that right now. I'll focus on implementing this not in my Roth IRA. But yeah, here's the problem is the drawdown, like for instance here. Um, that's a pretty significant drawdown. I go negative from, what is this, March 2020 to March 2021. So for over a year, there's a drawdown. Now 2020, yeah. Basically the COVID crash would have put me negative for quite some time, and actually it was losing, I missed out on the whole COVID recovery. The COVID recovery, I lost money till like August. Um, but that was a really good time for the stock market, so I'm missing out on all of that action. Meanwhile, the long only model recovered a lot during that period. So, I mean, this looks really good here, but, um, this would have done poorly for, it would have been, I would have had to trade this for 6 years before really getting good returns. That's bad. But the question is why, because I must be implementing something wrong. So portfolio optimizer, rules-based backtest, simple backtest. Top N. So simple backtest is only picking the top 20 Sharpe ratios. So top 20, top N. So short candidates. Cutoff, prediction, quantile. 1 minus self-dot threshold. If threshold is not none and threshold is greater than 0. Make the cutoff. Short candidates. Oh. So when I say here, where's Portfolio Explorer? Simple back test. Threshold. Is 0.5. I think there's a logic error here. The quantile of 1 minus 0.5. So why is it getting the quantile? Yeah, this is the problem. It just writes so much and I'm not sure what's going on. So if I go back to portfolio. So in portfolio, did I add that? Oh, good. Drop unnecessary. So that's what I want to do next. So I don't want to drop return from the buy. I want to keep date, account symbol, prediction, OHLCV. Open, high, low, close. So I actually only want to keep the open and close. So that I generate targets and features. So that I have the LGB model. This returns the LGB model. But before I can use the LGB model, I need to get the predictions. I'm trying to build for an income for myself that doesn't require a job. The workforce to military pipeline appears to be coming back. It's not a good look. Yes, it does certainly appear to be coming back. Hey, yeah, you should stream it. You know, the stuff. I didn't use AI before I started this, but then some guy commented doing AI. Yes, that is definitely the case. Your strategy is a relative rank strategy. That happens when you neutralize market risk. I need to understand the stock market more. Read some books. You can look at beta tilting on the longs using your relative rank system. Beta tilting on the longs. Okay, thanks, Sir Night Night. Also, I like Gemini Pro better than Claude. Compute the portfolio's weighted average beta at each rebalance and track it over time. So where's it recorded? Day betas dot set. Oh, day betas. Betas. So does it add rolling beta? Oh yeah. A mean portfolio beta of 1 means your longs have the same market sensitivity as the average, no tilt. If it's consistently above 1, your model systematically favors high beta stocks, which means your alpha is partly just leveraged market exposure. If it's below 1, you're picking defensive stocks. For a long-short strategy, you care about the net beta. Long beta minus short beta. If my portfolio, if my returns model is showing high predictive power with a monotonically increasing decile analysis, why would the my other idea is do a Gaussian process regression um, on the returns, given all the features, how uncertain is this return? I guess I could ask Claude about that. This is the most important diagnostic question for your strategy. The answer is almost certainly in your target variable. Target is cross-sectionally z-scored. Oh yeah, true. That makes sense. Yeah, we get it. Okay, so that makes sense. If I'm normalizing, this is a long short strategy. So I'm not going to worry about that. Optimizing the long only strategy. So now you have model. So you want to save the LGB model. Portfolio.get model predictions. This 10 years of top pool 95. I kill you if you try me for my Amex 95s. Need a better song. Oh, so I don't need this. So the predicted relative z-score. So I guess I don't need the portfolio level strategy, but the question is, if this has such predictive power, you know, maybe I just need to do this for the better, oh, the better back test. Like the fucking Predator. $2026-0408. So top end, do I want to make it more or less? I think 20 is good. Let's try 50 though. Loped and ready to get my saw going. I love my clip and slip my motherfucking toes on. But it should weight it. So we're getting the predictions, long candidates, short candidates. Weights. Oh yeah, also long short still is having a big drawdown, 40%. Yeah. Okay, Parcells album loved. Tired of the strain and the pain. Why is my internet going so slow? Yeah. Did I save this? Yeah. There's many things I wish I didn't do. Yeah, for some reason I can't pull up. The search isn't working. So I need to understand more really about portfolio construction. So I'm not going to worry about the long short strategy. Anderson Paak. I'm from Thousand Oaks, California, is where I was born and grew up. Anderson Paak is from like 2 towns over. And I heard there were two. I walked by a restaurant tonight and they were playing one Outcast song. What was it? It might have just been Miss Jackson. I kind of think it was. But then when I was walking back the other day, wait, what's the Outcast song with Outcast and 3 6 Mafia? I type a text to this girl I used to see saying that I chose this cutie pie with whom I want to be. What is that song? That's a really good song. Okay, now it's getting the features. Alright, portfolio, get model, generate target. So I'm just trying to get this working on just a single portfolio model. Walk forward portfolio. Don't worry about that. So that looks better. It still got killed in 2020. But look, after 2020, so when was it getting killed in 2020? I mean, 2020 is a good example of a shock event, so you don't want to get killed during that. But the drawdown was like 26 or 27%. But look, it's done pretty bad since here. So it looked really good like 2021 through end of 2024. But here it's basically doing nothing. Oh, UGK, yeah, that's right. Good, NGK. NGK knows UGK. Yeah, that's right. Anderson Paak is multi-talented. You met Big Boy. How'd you meet Big Boy? Oh, from music, duh. Music engineer guy. Yeah, Outkast is kind of a one of a kind in hip hop. Completely unique rhyme schemes. Alright, so when I have the portfolio, we're getting the portfolio, but before that I need to clean up the data. We don't need all this crap. So get model predictions. Uses greater than, oh good catch. Portfolio greater than or equal to, less than or equal to the end. Okay, then we're dropping the unnecessary crap. Then we're good. We only have date, account symbol, prediction, open, close, and the data frame. So rules-based backtest. First we add the rule set. So really I don't care about the features in the model. That'll be fine. It'll be in model.data. rules-based backtest. Okay, so now we can get that. So now add rule set. Self.df is equal to that. Name. So backtest rule, we pass a feature and a threshold. So now we can do define rules-based backtest. Add rule set. Self.rule set is that. So this should be in the rule set. Add rule info. I don't know that song. It's supposed to bubble. I don't know a lot of UGK songs. Oh, my 5 favorite rappers, that changes a lot. Um, I'd have to say all time over my whole life. Number one. Well, one and two have to be Lil Wayne and Eminem, but I'm not sure the order. Oh, and Kanye. So Kanye, Lil Wayne, Eminem, 1, 2, and 3. Tupac. Really, you can't say in order, so not in order. Kanye, Eminem, Lil Wayne, Tupac. 5. Who would 5 be? 5. That's hard. You could say so many different people, guys. Probably Nas. Am I missing anybody? Pretty basic list. Um, Juice World was really had amazing freestyles. He had amazing talent, but he only kind of rapped about immature stuff. Um, And then whoever owns the rights to his music raped his legacy. Um, yeah, that's a good list. Eminem, Kanye, Lil Wayne, Nas, Tupac. I'm trying to think if there's anybody I'm missing though. Let me look at my music. Who could I be missing? I mean, I guess I could really put Drake in there. I don't like Drake as a person, really, or as an artist, but his music is really good. Future, but probably Future's not in my top five. 50 Cent was pretty good for one album. Ooh, I don't know. I kind of like albums. 2014 Forest Hills Drive. I loved that album. I think I love every Kanye album up until Yeezus. And I like Yeezus. Yeezus has a lot of good songs, but I found it off-putting when it came out and I didn't like it until a lot later. Um then Life of Pablo was like schizophrenic. I thought way too many songs. God is. Oh no, that's a song. What's that album called? Jesus is King. That's an amazing album. Kanye's cool because he's so bold and interesting. You know, Eminem and Lil Wayne, they're just kind of always trying to push things lyrically. Same with Nas. But Nas had that album he released, I think it was in 2021 or 22. That was a really good album. I loved that song. Um, Man, what's he say? Uh, Something about girls from someplace. What is that song? I like Kanye has a song where he goes kind of recent with Ghostface Killa, and how's it go? Um, Me and Ghost in a ski mask. I was chilling in LA and Chilean like sea bass. That's probably one of my favorite lines ever. Nas. Oh, I don't think it's very popular, but I loved Nas's 2012 album. What was that called? Life is Good. Yeah, let's see. Eminem, Andre 3000, Lil Wayne, Black Thought. I don't know a single Black Thought song. What's a good Black Thought song or album? Nice, we're pretty similar, Sir Night Night. We got 3 out of the 5 the same. Alright. Oh, this. Did I exit out of that? Oh, I did exit out. It already ran, it wasn't good. It did good over some time, but it was really bad for long periods of time. Why am I running this? I'm not even thinking straight. Alright, so we have that. Then add rule info. So now we have the name corresponding to each rule. Drop unnecessary, get model prediction. So get model, then get model predictions. And then let's save it so I don't need to keep reading it in every time. Okay, so what do we want to, so first OS save, and let's pass a folder argument in. Oh, M-A-K-E, that's kind of confusing. M-K-dir and make dirs. So we want to save the model folder, and actually that's it. So folder slash info dot CSV, and then we can say Okay, then delete the model. And then put these guys in here. Portfolio folder / predictions.feather. Okay, we're going to initialize has data to false. Then if it's been opened, make it true. Then drop unnecessary. And then save. Don't need to do that. Okay, now I can read in a model that I've already saved. Drake, Skepta, Method Man, Tupac, 50, no order, plus a million honorable mentions. Oh, Talib Kweli, that's a good one. Oh. What they do. Okay. I'm gonna listen to it right now. If the search works. Maybe I just need to close the app, reopen it. Chuck D. Okay, that'll be my next one. Yeah, why is this not working? I think because it's trying to connect to Wi-Fi. Alright, let's get off the Wi-Fi. Yeah, for some reason search isn't working here. Let me try one more time. Alright, so we've got the model. So let's try getting it. Or we've got the portfolio. Get portfolio. Let me try again. Info dot model folder. Okay. Portfolio dot get model data. Oh, so I don't want that. So let's just go find it. Okay, so let's run model 22. Alright, let's make sure we get the same thing. Oh, but then I want to save it as. So model, yeah, but it's gonna have that bad feature. Alright, so back test rule set, rules based back test, add rule set. Get me higher than the grocery bill. Rule set dot add rule info. Okay, so now we have the rule set. Okay, so now I need to figure out how to do this efficiently. So rules, I could add any features. So um okay, this guy's still going. Come on, yo. Let's try one more time. Hey, it finally came up. Oh. Oh, good. Then this passes function. Um, I guess, yeah, let me get to the point tonight where I do the differential evolution on the rules-based back test. Well, let me just make a rules-based back test, then it'll be easy to add differential evolution. Now I need passes. Oh, so it does do a loop. I guess it's only looping through the dates. But I need to think about that more. Yeah, that's gotta be it for tonight. I gotta go to bed. Hey, Point. Do you use vectorization or event-based or a mix? I'm not sure what you mean by that. Yeah, all I have right now, I'm trying to make a portfolio model. I'm going through the process of figuring out how to make one. This is my returns model I've trained, and basically I'm just trying to get this to work. Now hold up. The cumulative long short spread looks really good. And May 25 to May 23 to the end of 25 looks really good. Here, May 23 to the end of 25 looks okay. But what's the return? Yeah, this is really good. Let me put some to-dos. Make option for walk forward analysis to use a set number of training years to use either or all training years together. Write in some portfolio optimizations. Incorporate, what was it called? risk parity. What else do I need to do? That should improve performance. I think that's all I got for now, so that's it for tonight. Oh, for the walk forward tests. Wait, let me see. Yeah, it's extremely computationally expensive. Like this model I just ran took a bit. I don't know, maybe I would guess maybe 15 or 20 minutes. But for the walk forward, I'm just sequentially running I'm splitting the data into training years, validation years, and test years for the walk forward. Um, and then, by the way, I listened to What Do They Do? It was good. No, I like, what era is this? Go to album. 96. Sounds very 90s. I like 90s rap. Um, for the walk forward, oh yeah, it's extremely computationally uh, expensive, but I'm not sure what vectorization or event based is for a walk forward analysis. But I'm basically doing one of these models for each one, but I'm training all the features at once. So, um, really, what takes a long time is generating the features. Once those are generated, it's training a different model for each walk forward. But I think that probably takes about an hour. So, takes a long time, kills my computer battery. Let me just make sure this is the same. That looks the same. Very good. Um, so I've written the portfolio, that works. The rules-based back tests, I'll try it. But really the one I want is the walk forward back test. Uh, oh, actually I don't even need to write a new one. I just need to write, I need to write this class, walk forward portfolio. Then I could feed either a single portfolio or a walk forward portfolio into here, and test out the rules based back test. I need to, oh yeah, change the walk forward so it's using all years available to it, not just the most recent years. I think that should improve performance. And then redo the walk forwards for the different models using that. Um, and then yeah, keep building out this portfolio script. Um, look into hierarchical risk parity. Thanks, Sir Night Night, for that suggestion. And I realize that generally I need to become more educated on modern portfolio strategies because I don't really know anything. So that's it for tonight. Thanks for watching. Have a good rest of your night. Adios. Oops. Um, look into hierarchical risk parity. Thanks, Sir Night Night, for that suggestion.